Okay, inverse trig functions. This, for the first part of it, will be review of what we just did on the last unit. So part 1, review. Find theta such that 0 degrees is less than or equal to theta, which is less than 360 degrees. Okay, number 1, sine of theta equals 1/2. Do you guys remember these? We just fit when we the end of the unit. These were on the test. Do you guys remember them? Yes. How many answers did we come up with? 2. Could 360 be one of the answers? No. Instead of 360, we use 0. Okay. So what we think of is, first, what is our reference angle? You either use your unit circle, you have it in your head, or you use your finger trick. When is sine 1/2? 30. So 30 degrees is my reference angle. And then I figure out which 2 quadrants am I in. What happened? All students take calculus. What 2 quadrants is sine positive? First and second. So is 30 degrees one of my answers? Yes. Why? Because I'm in quadrant 1. All right, 30 degrees, and what is 30 degrees in quadrant 2? 150, right? Because it's 30 degrees, so you do 180 minus 30, and you get 150. If you want to do radians, you can. It's up to you. I'm just going to leave it as degrees for now. Questions? Do you guys remember these problems? All right, one more. Number 2. Sine of theta equals negative 1/2. What's our reference angle? Is it still 30 degrees? Yes, it is still 30 because it's still 1/2. The only thing that changed is it, instead of positive, it is negative. So we still use this, the ASTC. And which 2 quadrants is sine negative? 3 and 4. So is 30 degrees, will that be one of my answers? No, it's not, because I'm no longer in quadrant 1. So if I'm in quadrant 3, will I do 180 minus 30 or 180 plus 30? Plus, and that's 210. In quadrant 4, do I add or subtract from 270 or 360? Yeah, never the 270. All right, or the 90. So you do 360 minus, and what is it? 330. All right, any questions on this review? Okay, what we're going to do today is work with the inverse sine and inverse cosine, and actually inverse of all our 6 trig functions. Okay, now when we're working with the inverse functions, let's write it down. Part 2, inverse functions. All right. Number 1. Sine of theta equals 1/2, and I do have a restriction for you, so write this down for now, because did we not just do this problem up here? Yes, but there's a restriction now, so I'm going to write it down. Negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. All right, so we now have a restriction to where our answer can lie. What is negative pi over 2? It's at the 270, yes? Okay, so that's here, and where's the pi over 2? Pi over 2. So I can only be in which two quadrants, according to my restriction? 1 and 4. Okay, is sine positive in both quadrants or just one? Just one. So how many answers will I end up with? Just one. And what's my one answer?
30 degrees.
30 degrees. Okay, so how is that different from up here? Up here, how many answers did I end up with? 2. Now, how many do I end up with? 1. Why? Because there is a restriction. According to my restriction, I can only get answers that are in quadrants 4 or 1. And if I'm in quadrant 4, I don't call it 330. What would I call it? Negative. Negative 30, negative 60, negative 45, according to this, because I'm going from negative 90 to positive 90. So anything in quadrant 4 is going to be negative. Do you see that? All right. Let's try another one. Number 2. Sine of theta equals negative 1/2. And I'm going to give you the same restriction. So let's write it down again. Negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. Can anybody tell me why up here I don't have the equal bars on both, and I said it was not okay to because 360 and 0 are the same, but why is it okay to have it here on both of them?
Because they're not the same.
Because they're not the same is correct. Negative 90, positive 90. All right. So once again, I have my restriction. Bless you. Negative pi over 2 to positive pi over 2. If I'm in this restriction, what two quadrants am I allowed to use? 1 and 4. This one says sine is negative. Where is sine negative? I can only use these two, in 1 or 4? 4. So would I use 330 like I did, like I did earlier? No, because it's negative 90 to positive 90, or negative pi over 2 to positive pi over 2. So what would my answer be? Negative 30. Yes? Mm-hmm. Say your question. Why can't what? Oh, why would I not use 330? Because according to this restriction, I'm only allowed to use angles that are between negative 90 and positive 90. And 330 is not between negative 90 and positive 90. Okay, so according to this restriction, negative pi over 2 and pi over 2, and 330 is way out of that range. It's all the way completely around the other way. Does that make sense? All right. Okay, so why do we have these restrictions? Inverse sine, inverse cosine, inverse tangent, all these inverse functions will from now on only have one answer, like this. And when you plug it in your calculator, you only get one answer. We don't use our calculators on this unit, but I do want to show you. Inverse sine of 1/2. Do you see, it's kind of small here, but right above, or you may have noticed on your own calculator, and you used it in math too, right above the sine key, do you see that little sine -1? Yeah. So if I typed it in, second sine, that's saying inverse sine, I can type in 1/2 or 0.5, and the answer is 30. And is that what we got here? And only 30. So let's try it again for negative. What do you think the answer is going to come out to be? Okay, so let's try it. Am I in screen? Clear second sine, that means inverse sine of negative 0.5, and the answer is negative 30. Okay, do you see how that works? So the calculators are programmed as well to have this same type of restriction. Any thoughts on why it uses, for sine, why it uses these two and not the top two? Good job. If they were the top two, sine would be positive in both of them. And if I need one where it's positive and one where it's negative, does it make sense that we're using this side here? It's not the only possibility, but does it make sense on why we're using the right side and not the top side? Yep. We never use quadrant 3. Yes. Just stretching. All right. Let's try another one. Number 3. Cosine of theta equals -1 over root 2. And I have a restriction for this one as well. Are we ready? 0 is less than or equal to theta, which is less than or equal to pi. What two quadrants am I restricted to now? Between 0 to pi? 1 and 2. Do you guys agree? This is 0, this is pi, yes or no? Okay. So will I have any negative angle answers? Like over here it was -30 and here it was 30. Will I have any negative answers here? No, because 0 to 180, there are no negative angle measures. Do you see that? Yes. And over here, if you didn't put 30 because this is in radians, could you have put pi over 6? And here as well, -pi over 6. Okay. All right, so back to this one. We're between 0 and pi. So in this particular case, cosine is negative. Which quadrant am I going to be in? 1 or 2? Now, again, I want to emphasize it's not going to be a negative answer. Over here it was because quadrant 4 is negative according to -pi over 2 to pi over 2. Got it? All right. What's my reference angle? Let's address that first.
45.
45. That's one we should have memorized without our unit circle, without our hand trick. What is 45 degrees in quadrant 2? 135. Or pi over, not pi over, thank you, what is it? 3 pi over 4, thank you. All right, your choice and how you write your answer. Questions? Yes? Yes, yes. Well, it doesn't have to be, but technically, yes, it should be. But if you gave me that answer, I would not mark it wrong. Okay, but yes, he's saying, shouldn't we write it in radians since our restriction is in radians? Yes. Okay, so same question I asked you before. Why do you think for cosine the restriction is the top 2 quadrants and not the right side like we did for sine? I'm going to repeat the question. I want you to think about it. Why do you think for cosine we're using quadrants 1, we're restricted to quadrants 1 and 2 instead of 4 and 1 like we did for sine? Okay, so why? It's involving our x values. If I did the right side, cosine's positive and cosine's positive. Do you agree? And if I did the right side, would I ever end up with cosine being negative? Or how would I address cosine being negative? Because cosine is never negative in these 2 quadrants. Do you see that? So in this case, up here, I had one quadrant where sine was positive and one quadrant where sine was negative. And in here, do I have the same case for cosine? One where cosine's positive and one where cosine is negative. And which quadrant did I say we would never use? Quadrant 3. It's either going to be the right side or the top side. 1 and 4 or 1 and 2. Got it? Okay, any questions on this before we move on? Okay, we are going to write down our restrictions. And it's important that you remember why sine is on the right side and why cosine is on the top side, because it helps you remember the restrictions we're about to write down. So let's go over it one more time. Why is sine on the right side? One positive and one negative. Or if it was the top, sine is positive in both, correct? Okay, why is cosine on the top side? One positive and one negative. If it was on the right side, cosine would be positive in both. All right, so we're going to write down our restrictions now that you're going to have for all 6 trig functions. All right, and we are ready. Inverse sine of x. Inverse sine. You'll see it written like this with the little -1, inverse sine. You'll see it written as arc sine. different ways, and we'll see some in the examples. Okay, our restriction for this is just like we had right up here. Negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. All right, cosine, inverse cosine, will always be defined between, just like we had right here. 0 is less than or equal to theta, which is less than or equal to pi. And the one that we haven't seen yet, inverse tan, will always be defined just like inverse sine. Negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. And we'll see a little more why when we graph it, when we graph tangent and inverse tan, how it works. I'm going to come back up here and just note that tangent is positive here and negative here. Do you guys agree? Also positive here and negative here. So both cases work, but what side do we use for the tangent for inverse tan? The right side. All right. Questions before we work with the reciprocal functions? Okay, the first two reciprocal functions are pretty straightforward. Just a reminder, or get you guys thinking, what's the reciprocal, not inverse, what's the reciprocal of sine? Cosecant. So inverse of cosecant. What's nice about the first two of these here, they match. So cosecant matches sine. So negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. And for the same reason as before, sine is positive quadrant 1 and negative in quadrant 4. Same thing with its reciprocal function. Cosecant is positive here and negative here. Got it? All right, what's the reciprocal of cosine? Secant. And it matches, just like with its cosine. 0 is less than or equal to theta, which is less than or equal to pi. So these two are pretty straightforward. Tangent and cotangent are the only ones that do not match. Cotangent x, if they don't match, what's the only other option? If it's not between negative pi over 2 to pi over 2, it's going to be 0 to pi. All right, are you ready? Make sense? Okay, so there will always be 3 and 3. 1, 2, 3 between negative 90 and 90, and 1, 2, 3 between 0 and 180. Okay. For sine and cosine, we've talked already about knowing how they work. Why are you on the right side versus why are you on the top side? So practice that because you will need to have that memorized. Are we ready? Okay. So we're just going to quickly get down or write down what it is that we just learned. Okay. Negative pi over 2 to pi over 2. Which one's on the right side? And we're going to review which one's on the top side. 0 to pi. All right. Which one was on the right side? Sine. Let's ignore tangent for now. And we know sine is on inverse sine because it's positive here and negative here, correct? Couldn't be at the top because they would both be positive. All right. Ignoring tangent and cotangent, which one's here? Cosine. For the same reason, it's positive here and negative here. where if it had been top and bottom, that wouldn't work because cosine's positive, cosine's positive. All right. So it's easy to memorize for the sine and the cosine inverse functions. It's tangent and cotangent that you have to think a little bit about. Which one is tangent? First one? Inverse tan. Look back at your notes. It's there between negative pi over 2 to pi over 2. And this one is cotangent. Got it? Now, whatever you need to do to have these memorized. We've talked about sine and cosine, and to me, if you remember the whole positive negative business, it's pretty easy to remember. I had a kid come up with this years ago, and she said it worked for her, and other kids said it works for them. She thinks of this as a B, and she said you get a suntan at the beach, and that's how she remembered it. You get a suntan at the beach, and so she remembered the sideways one was sine and tangent. Do whatever works for you. The other one, if she used sine and tangent here, then that only leaves cosine and cotangent for the other one. So, yeah. All right, evaluate. Okay, inverse sine of negative root 3 over 2. All right, now this is where kids, like, it just messes kids up. I'm going to put an equal sign. Do you see the difference from the way I wrote it here and the way I wrote it here? Yeah. Here I put sine of theta equals. Now, we've not seen it like this. Typically, the way we write our sine functions is something like this: sine of 30 degrees or sine of pi over 6. This here is always an angle, 30 degrees, pi over 6. Is negative root 3 over 2 an angle measure? No, it's not. It's an answer to one of our trig functions. So why am I able to write it next to the sine? Because this is the what? Inverse. This is the inverse of sine. This is how you are thinking of it in your head. This is pretty much saying sine of what angle is negative root 3 over 2. That's what this is asking. So when you plug this type of problem in your calculator, you're asking your calculator, hey, at what angle is sine negative root 3 over 2? And this shoots out the angle. We don't use our calculators. We're going to use our unit circle or your hand trick. Okay, first off, let's process. Which two quadrants is sine defined? Top 2 or right 2? The right 2, right? It's right here. Okay, it's negative. Is that going to be quadrant 1 or quadrant 4? 4. Don't forget quadrant 4 is negative. It's the only one that's negative. All right, so we will have a negative answer. You either use your unit circle, so you're looking at it right now, or you use your hand trick. Sine is what? X or Y? Y. So when is it root 3 over 2? When I put this finger down, what is that? 60 degrees. So it would be negative 60. Good job. Or negative pi over 3. All right. If you didn't like the hand trick, then you're looking here at negative 60 degrees. It would be, it matches up here with the blue, negative root 3 over 2. Do you guys see that? Yes? All right. Questions? Okay, so remember, sine, cosine, tangent, you're taking sine of an angle. Inverse sine, inverse cosine, inverse tangent, you're taking sine of these answers here and looking for the angle. Do you see the difference? Okay, so let's try another one. This was number 1. Number 2, inverse cosine of 1. Okay, so again, why is this not an angle? Because this is an inverse function. Where is cosine defined? Top half or right half? Top half. We know that because it's positive and negative for cosine, and it's right here. The only time we get 1 is when for cosine and sine. quadrantals. Good. For tangent, it's at 45, but cosine and sine, it's at the quadrantals. 1, 0, -1, 0, and 0, 1. I'm looking when cosine is 1. Cosine are your x values, so when does that happen? 0. Is there any way I can write 360 as my answer? No. Our restriction for inverse cosine is between 0 to pi. Got it? So no 360 because that's way out of your range. So 0. 0 degrees or 0 radians. Got it? All right. Number 3. Actually, I'm going to squeeze 3 over here. Number 3. Arc sine of √3 over 2. Okay, now I said earlier, you're going to see it this way or with the arc. They mean the exact same thing. So make a note to yourself, either in your head or on paper, exact same thing. This is, again, asking yourself, sine of what angle is positive √3 over 2? This is what you're asking yourself in your head. So we're looking for an angle answer. How do we know our answer is going to be an angle? Because we're dealing with the inverse functions. When you're dealing with the inverse functions, your answer will be an angle. Okay, so where is arc sine defined? Top half or right half? Right half? Positive, negative? It's positive √3 over 2. So which quadrant, bless you, which quadrant am I going to be in? 1. So positive or negative? Positive. All right, so you use your unit circle or you use your hand trick. Sine, we want to be √3 over 2. So when does that happen? 60 degrees. Or pi over 3. All right. Getting the hang of it. Yes. What was that? Yes. Number 4. Arc cotangent of negative √3. You can take a picture and write it down, but I need this back. Okay. All right. So, arc cotangent, not as easy as one of the ones that we have memorized. So you can remember sideways. What was it? Suntan at the beach. So, thank you. Would cotangent be on the right side or the top side? Top side. It's negative. So this is 0 pi. It's negative. Which quadrant are we in? 2. Am I negative in quadrant 2? The only quadrant I'm negative in is which quadrant? Not 2. Okay, I'm saying that wrong. This is negative, and I apologize for saying it the wrong way. Is my angle answer going to come out negative? No, that's what I was trying to ask. Is my angle answer going to come out negative? No, like this one up here? No. Why did this one come out negative? Because I was in quadrant 4. All right. So, cotangent is, tangent is y over x, yes or no? Yes? So cotangent is x over y. So we want it to be √3 over 1. Does that happen when this finger is down? √3 for x over 1. What angle measure is this? 30. So 30 is your reference angle. What is 30 degrees in quadrant 2? What is it? 150. 150 or pi, nope, 5 pi over 6. All right, number 5. Arc cosine of cosine, that's 7 pi over 2. All right. Now, I really want to spend some time on this one. How is this different from the other ones? There's two pieces. It's like a composition. You know, remember when you guys did f of g of x before? Yes? You guys have done that before. Composition of functions. We're doing arc cosine of cosine. So I'm going to cover this. You will never do inverse of an inverse. Okay? This is the inverse. This is not the inverse. Do you see that? And it's not always going to be this order. Sometimes the non-inverse will be on the outside. I'm going to cover this. This is regular cosine. 7 pi over 2 is an angle. Do you agree? So our answer here is going to be like 1 or root 1 over root 2 or root 3 over 2 or something like that. Got it? This is an inverse. What kind of answer do we end up when it's an inverse? A degree, an angle. Radians or degrees. So whatever's on the outside is going to be your final answer. So what is our final answer going to be? An angle. Whatever's on the outside is going to be your final answer. And since it's an inverse, an angle is going to be our final answer. All right, so I do this part first. What's cosine of 7 pi over 2? Where is 7 pi over 2? 1, 2, 3, 4, 5, 6, 7. Is this 7 pi over 2? Yes or no? Yes. And what is cosine of 7 pi over 2? 0. So I have arc cosine of 0. Where is arc cosine or inverse cosine defined? Top. Okay, so I'm going to label these quadrants. The bell's going to ring soon, so I'm going to try to hurry this up. And I'm looking for when cosine is 0. Where does that happen in these? 0, 1, 90 degrees, or pi over 2. Now, if you're like, okay, I don't know what she's talking about, we'll spend more time on this one tomorrow. I'm going to write this one down. When you get to this one on the homework, you're going to skip it because I've not gone over it with you. So let me show you which type you're skipping tonight. Write it down. When you get to it and you're like, what the heck is this? When are we going to do it? Tomorrow.